Hello everyone, my name is İSMAİL Kalaycılar. I am working as PhD student in Istanbul University Cerrahpaşa, Faculty of Veterinary Medicine, Department of Biochemistry. I am gonna tell you about my presentation of pros and cons of using microRNAs as biomarkers. This is my presentation plan. What is the microRNA? MicroRNAs are short RNA molecules, 19 to 25 nucleotides in size that regulate post-transcriptional silencing of target genes. A single microRNA can target hundreds of messenger RNAs and influence the expression of many genes, often involved in a functional interacting pathway. mRNA mimics and mRNA inhibitors currently in preclinical developments have shown promise as novel therapeutic agents. Multiple technological platforms have been developed for mRNA isolation, mRNA quantitation, mRNA profiling, mRNA target detection, and for modulating mRNA levels of in vitro and in vivo. How it works in the organism. First step, mRNA isolation. Second step, mRNA expression detection. And the last step, target detection. mRNA can be isolated from cells, tissue, and body fluids such as serum, plasma, tears, or urine. The early work published in the field used the traditional phenol chloroform extraction followed by RNA precipitation. A widely used reagent is triazole. However, there is often the presence of high level of contaminants using this method. In addition, it has been found that mRNAs with a low GC content are selectively lost during phenol chloroform extraction from a small number of cells. And this is due to the inefficiency of precipitating small nucleic acids compared to long nucleic acids. Using a column-based RNA absorption method during mRNA isolation avoids these issues. The initial column-based method involves loading the aqueous phase from the phenol chloroform extraction onto an RNA absorption column followed by wash and deletion of microRNA. The Mirvana and Mirvana kits are two widely used kits for this method. Newer commercially available kits such as the Diaxol kit skip the phase separation step. The phenol reagent containing mRNA can be directly loaded onto an RNA absorption column followed by wash and elation of microRNA. mRNA expression detection. mRNA expression can be detected in both tissue sample as well as in cell-free biological fluids such as serum or plasma. Current methodologies used for detecting mRNAs include quantitative PCR, in situ hybridizations, microarrays, and RNA sequencing. Because the length of mRNA is typically only 21 to 23 base pairs, it's technically challenging to design PCR primers as the conventional PCR primers about 20 base pairs long. The solution is to extend the length of mRNA during the reverse transcription step by either utilizing a mRNA specific stem loop primer for transcription or universal reverse transcription by adding a 3 poly A tail to the mRNA and then use a poly T primer with the universal sequence appending at the 3' and for reverse transcription. Subsequently, qPCR is performed with forward primer probe that are specific to each mRNA and reverse primer complementary to stem loop or universal scans of poly T primer. A universal adapter can also be added to 5' and allow an optional universe preamplification prior to qPCR for detection of very low abundance target with primer probe. Compared to universal reverse transcription, the stem loop prime based method has a higher specificity, but the reverse transcription step is limited one mRNA at a time. MicroRNAs mediated post-transcriptional gene silencing of target genes by targeting the 3' under untranslated region of messenger RNA with the seed region. Enucleated 2 to 7 in the end, 5' end of mRNA being the crucial sequence. From a transient double strand mRNA duplex, the guide strand is incorporated into RNA-induced silencing complex to mediate gene silencing and the passenger strand is degraded. What are the biomarkers? There are several more precise definitions of biomarkers in literature, and they fortunately overlap considerably. In 1998, the National Institute of Health Biomarkers Definition Working Group defined the biomarkers as a characteristic that is objectively measured and evaluated as an indicator of normal biological process, pathogenic process, or pharmacologic response to a therapeutic intervention. Usages of microRNAs as biomarkers in the organism. Since mRNAs are highly specific for gene regulation, altered expression patterns of these molecules indicate dysregulation of important biological process, which is often the cause of these. In the past decade, aberrant mRNAs expression has been demonstrated in several diseases, including several types of cancer, cardiovascular and rheumatic disease, as well as neurological disorders. Since unique mRNAs expression signatures have been demonstrated in clinic tissue samples, it's not surprising that mRNAs have been proposed as novel biomarkers in diagnostics. Rather than individuals' mRNAs, the signatures of the most important mRNAs in disease have been used as biomarkers. Pros of using microRNAs as biomarkers. While conventional cancer markers are mainly produced by tumor tissues or normal embryo tissues, they are absent or present in very small amounts in tissue and blood of healthy adults. Among the traditional cancer markers that are currently identified are alpha-fetoprotein, carcinoembryonic antigen, and carbohydrate antigen. They are generally broad-spectrum biomarkers for the diagnosis of various types of cancer. CEA, CA199, and CA125 are biomarkers that are generally accepted to have positive predictive value as circulating biomarkers for different cancers. Among other screening strategies, we can give example of biomarkers such as mammography for breast cancer, colonoscopy for CRC, and prostate-specific antigen for prostate cancer. However, we can state that mRNAs, which are more effective, accurate, specific, and sensitive screening biomarkers than traditional biomarkers, which are still lacking to fulfill detective and predictive functions in the care of cancer patients, have a certain advantage as a potential clinical application. In particular, it has become quite easy to obtain circulating mRNAs without serious damage. Moreover, several potentially effective mRNAs biomarkers are stable in healthy humans. Expression level may not be clearly influenced by age, gender, body mass index, smoking status, or other baseline characteristics when assessing pathogenic potential. Therefore, the altered expression pattern can be included in routine examination for monitoring and early detection of cancers. Until now, polymerase chain reaction is still the main and reliable examination technology for circulating mRNA. Amplification is a critical step and feature for any PCR that magnifies the initial difference between samples, even if the difference is quite small. Therefore, the current and routinely used PCR method makes circulating mRNAs more sensitive biomarkers. Cons of using mRNAs as biomarkers. The majority of potential mRNAs biomarkers are found in both healthy individuals and cancer patients. Difference in expression levels between healthy people and patients are usually quite small. Therefore, the sampling route must be ignored in order to accurately distinguish cancer from healthy condition or other benign injuries. For this reason, this situation can be expressed as a disadvantage. mRNAs are obtained from venous plasma or serum. The mRNAs profiles in venous and arterial plasma are broadly similar. Therefore, the levels of most mRNAs may not have a significant difference between venous and arterial. Therefore, blood sampling methods for some specific mRNA biomarkers should be carefully considered. Circulating mRNAs have broad promising potential to scientific community to serve as effective non-invasive cancer biomarkers for clinical application. It's thought that mRNAs may be valuable in several aspects, such as screening for early-stage cancer, drug sensitivity prediction for subtypes classification and treatment strategy selection, and screening for chemo or radio resistance of tumor for the prognosis of outcomes and relapses. Even though high costs demand on qualified person to practice wet lab, and stability problems can't on limitation list of microRNAs, the research biomarker were opened a new page in epigenetic research with its priorities like specificity and ability to design personal and targeted treatment. Larger scale studies are expected to further promote the sensitivity, specificity, and applicability of potential circulating mRNA biomarkers in the future. Thank you for listening.